Alright, ladies and gents, this is lesson 1-2, linear measure, segment addition. I'm going to walk you through it. So, one famous phrase that we say in all our geometry classes is that small plus small equals big. Meaning, if we had, let's ungroup this. If we had one blue piece, say that it's 5 feet long, and then we had a red piece that's 3 feet long. We know if we put the red piece plus the blue piece, we put them together, it'll make a total of 8 feet. It's putting two pieces together. Now, I'm just saying that this green piece is equal to 8. So the blue piece plus the red piece is equal to the green piece. Small plus small equals big. Alright, let's put that concept, let's do some more numbers here. So our goal here is to solve for x. And this is our problem over here. RS has a length of 5x. ST has a length of 4. And we know the total length from R to T is 29. So we know the blue piece, 5x, plus the orange piece, 4. Those two added together is going to equal 29. So we can make an algebraic expression out of this. We could say 5x plus 4, the blue guy plus the orange guy, is equal to the red one. It's equal to 29. And then we do our inverse operations from there. We subtract 4 from both sides. And we're going to get 5x equals 25. We then divide by 5 to both sides. And we get x equals 5. So that's how you would solve a problem like this. Next up, we got 3x and 24 and 51 here. So RS is a length of 3x. ST is a length of 24. The whole length from R to T is 51. So the blue one, the blue piece 3x plus the orange piece 24 is equal to the red piece 51. So we put an algebraic expression to it. We say 3x, that blue piece, plus the orange piece 24 is equal to the red piece 51. We then do our inverse operations. We subtract 24 from both sides. So we have 3x equals 27, because 51 minus 24 is 27. We then divide by 3 to both sides. And we get x equals 9. Let's do another. So once again, we're solving for x. The blue piece plus the orange piece is equal to the red piece. So we do 4x, the RS, plus the ST, the 14, is equal to the 48. We then subtract 14 from both sides using our inverse operations. So 48 minus 14 gets you 34. We then divide by 4 to both sides, and we get x equals 8.5. Yes, these do get complicated. And we're just starting with the easy ones first, and we're going to work our way up. So I think we got one more of these. So we got a problem like this: 5x, 34, and 56. Same procedure. This length, this blue length 5x, or the length R to S, plus the length of S to T, is equal to R to T. So 5x plus 34 is equal to 56. So we write that equation down. We then subtract 34 from both sides, and we get 5x equals 22. We then divide by 5 to both sides, and we get x equals 4.4. So don't be shocked if you get decimals once in a while. That is okay. Alright, here's just a different way where it's a little bit harder because of the presentation, but it's the same material. It's just presented a little bit differently. I do believe you can handle it. So, what does this say? On PQ, to say that point M is between points P and Q means P, Q, and M are collinear, meaning that all three of these letters are on the same line. And PM plus MQ equals PQ. So let's make a visual out of this. We have a line, because that's what collinear is. All three of these points are on a line. We know it's 3 points, so I'm making 3 dashes. I could label it. We know P is involved. We know M is in between P and Q, so M is in the middle. And Q. Result in the end. So they're saying, in words, they're describing this picture. So we have to change the words and make a picture out of it. I have to make a model. So PM, this length, plus MQ, this length, is equal to PQ. So it's the same thing that we've been doing. Just given to us in words. Alright, so now they have RS is equal to 5x, ST is equal to 3x, and RT is equal to 48. Here's a nice little line, a little picture of it. So we have RST. We're told that S is between R and T, so I put S in between R and T. And then it's the same type of problem that we've been doing. We do RS plus ST. So we get 5x plus 3x equals 48. We then combine like terms. 3x plus 5x gets you 8x. So 8x equals 48. We then divide by 8 to both sides. And we get x equals 6. We'll do another one. Find the value of x if RS find the value of x and RS if S is between R and T. RS is 2x. So RS is 2x. ST is 5x plus 4. And RT, the entire thing, is 32. So we know 2x plus 5x plus 4 is equal to 32. So we make that equation out. Which I have it right here on the right hand side. We combine like terms, do inverse operations, and we solve for x, just like we've been doing in Algebra 1. Let's look at number 3. Here's our picture on the bottom. This is our words for it. And here's our work. Doing our inverse operations, we find that x equals 10. Alright. So it says find the value of x and RS if S is between R and T. So I'm just solving for x here. To find out the value of RS, we would just plug in that x value back in for the x for the RS. So this one would be 4 times whatever x value is will get us the other answer. Or the answer for RS. So we have RS is equal to 4x, ST is equal to 4x, and RT is equal to 24. So we know 4x plus 4x equals 24. 4x plus 4x equals 8x. Then we divide by 8 and find out that x equals 3. Now we want to find the value of RS also. So RS we know is equal to 4 times x, and we know our x value is 3. So 4 times 3 is 12. So the value of RS is 12. Alright. Now, these types of problems can get bigger and harder, but since you know the concept, you can apply what you know and complete these problems correctly. I just got to be a little bit more diligent, a little bit more patient. Now to help make things a little bit more sense, I use candy bars. We know that we could have one big strip of chocolate here. 5 pieces. 1, 2, 3, 4, 5. That entire thing. We know that's the sum of one plus another plus another plus another plus another. You know this full candy bar is the same as 5 pieces being put together or added together. So we're going to apply that same concept to math problems and segment addition. This segment plus this segment plus this segment plus this segment plus this segment. These 5 segments are equal to this one candy bar. Alright, so let's take that concept and let's apply it here. We know x plus 10, this piece, plus this piece of 24, plus this piece of 18. These 3 pieces added together equal this blue piece of 70. So when we make our equation, we're going to put all 3 of them together. So it'll be x plus 10 plus 24 plus 18 is equal to 70. That's what I did here in this bottom line. I then combine like terms. X plus 10 plus 24 plus 18. Those 3 numbers add together get 52. Subtract 52 from both sides and I get x equals 18. Let's look at this one here. Same concept. This piece of 35 plus this piece of 5x plus 25 plus this piece of 10x is equal to this blue piece of 105. So these 3 pieces added together is equal to this 105. So I write that equation out. And this is what I get. 5x plus 25 plus 35 plus 10x equals 105. I combine my like terms. 5x and 10x gives 15x. 25 and 35 get combined to 60. Subtract 16 from both sides and then divide by 15. I get x equals 3. As you can see, it could get bigger and harder. Now it's 5 pieces of candy is equal to this one big candy bar. Same concept though. You just add them all up together and set it equal to the big piece. Combine like terms and then solve for x using your inverse operations. Now this is when it starts to get a little bit more tricky. We know that ST, this piece ST is plus TU, the x plus 19, plus UV. All 3 of those pieces added together is going to equal x plus 36, this blue line. However, we don't know the values of ST and UV. We have to figure those out on our own first. And then we'll plug them in. So what I do here first, I see that ST, this little piece, plus this 23 piece, these 2 pieces added together is going to equal the entire thing. So I'm going to say ST plus 23 is equal to this big piece, x plus 36. I then do inverse operations to get ST by itself. And I find out that ST is equal to x plus 13. So I write it in. ST is x plus 13. Now I want to find out UV piece. Well, I know this UV piece plus this piece SU, aka the 24, those 2 pieces added together will also equal the x plus 36. Or I could say UV, this UV piece plus the x plus 19 is equal to the 23 piece. Either way works. So I'm going to do UV plus x plus 19 equals 23. I'm going to subtract the x plus 19 from both sides. So I get UV is equal to 23 minus x minus 19. Combine like terms, UV equals 4 minus x. So I write that in for UV. The last piece that I do, I say st plus tu is equal to 24. So st x plus 13 plus tu x plus 19 is equal to this 24 piece. I combine like terms. I do my inverse operations. And that's how I solve for x. So I got x equals -4. Obviously it's a little bit bigger, a little bit more challenging. Here's another one. This is very similar to what we already did before. IJ is 4, JK is 3x minus 21, KL is 3x minus 14. We know we just have to add these three pieces together and set it equal to the 29. So here's my work for it. That's the answer. This piece. This one's a little bit tougher. What I did here, I see that the 3x minus 9 plus this random KL is equal to 19. We also know 16 plus KL is equal to 8x. We also know this 8x plus the 3x minus 9 is equal to the entire thing. And we know the entire thing is this 19 plus the 16. So 19 plus 16, you know, is 35. So we know the entire thing is 35. So I'm going to write that one in. We got that from this 19 plus LM, the 16. You know, that's 35. So that's why I did a little blue line and 35 there on top. So now with that being said, we know 8x plus 3x minus 9, these two pieces added together is going to equal to the big piece. So 8x plus 3x minus 9 is equal to 19 plus 16, which we already determined was 35. 8x plus 3x gets you 11x. Minus 9, we continue our inverse operations, which you don't need me to explain. We get x equals 4. There's another one you can practice with. You hit the pause button. And here's my work, so you can compare your work with mine. There's my work on the side. Alright, why don't you practice with this one, and then I'll give you my work, so you can hit the pause button. So there's your problem. Try it on your own first. Hit the pause button. I know JK is 14. And here's my work. So you compare your work to mine. We know 27 minus 13 is 14. So 27 minus 13 gets us to 14. That's why I put the 14 in there. And then we know 14 plus 2x plus 31 is equal to x plus 31. These two added to that. Use inverse operation, we solve for x equals negative 14. Here's your classwork, homework. If you have any questions, please email me or come to Next Drop. I'll be happy to help you out. All right, have yourself a good night.